NIR is near-infrared spectroscopy, which is a technique which uses light which has been absorbed by wood between about 1100 and 2500 nanometres. That gives us some information about the chemistry of the wood, how the chemistry of the wood varies, affects how much light is absorbed and how much light is reflected. And using statistical modelling, we can actually then build calibrations which will allow us to get an indication of what the wood properties or the chemical properties of the tree are. If we can maximise the pulp yield and the volume and the density, it's just another factor that helps breeders and plantation growers to get a better productivity, a better profitability out of their land. Our laboratory NIR is now routinely being used by industry for predominantly breeding applications. And as we take our portable near-infrared out into the forest, we are slowly building those calibrations that the industry can have trust in so that they can actually use it and measure the kraft pulp yield in real time. The main benefits of the technology is that it empowers the industry to get critically important wood property information that they've previously been unable to get more quickly, more cheaply and more broadly across a greater number of samples. For example, if we wanted to cut down one of these trees and measure its kraft pulp yield, the standard industry method would require cutting it down, taking about 10 kilograms of wood chips or discs from that, sending it to pulp yield, and the cost of that is between about $800 and $1,000 per sample. The portable near-infrared instrument that we're using costs between $20 and $30,000 US, compared to our laboratory instrument, which costs between $100 and $150,000 US. So that then allows the industry, if they wanted to buy their own, to do it much more cheaply than they have previously been able to do. And then building those calibrations, once those calibrations exist, it's just as simple as pointing your instrument at the wood sample, collecting a spectra, and you've got your prediction. Kraft pulp yield is just one property. We are building calibrations for cellulose content, wood density. So from the single analysis, from a single collection of one spectra, we should be able to use this technology to also predict cellulose content and wood density. And then the opportunities now with our other laboratory systems to actually use NIR to measure wood stiffness. And also we could potentially go down the route of calorific value, biofuels type application. In terms of the cost effectiveness and building all this up for industry, it's really the only way to cheaply and quickly get this data.